Let's explore JavaScript timing functions. These are essential tools for controlling the timing of code execution. Using these, you can create efficient and high-performance code. The setTimeout function is a timing function that executes a callback after a specified delay in milliseconds. It is perfect for delayed execution of code, creating timeouts for operations, implementing debouncing, and breaking up long-running tasks. The basic syntax of setTimeout includes a callback function and a delay in milliseconds. For example, a greet function that logs hello is called using setTimeout with a delay of 2000 milliseconds. We can also use an inline function, like here, logging a delayed message after 3000 milliseconds. Let's explore some advanced features of setTimeout. You can store the timeout ID, returned by the setTimeout function, into a variable, and then use clearTimeout method with that ID to cancel the scheduled timeout. It is good to check if a timeout ID exists before calling clearTimeout. You can also pass parameters to the callback function. In this example, the greetUser function, which expects name and title, is called with John and developer as parameters after a delay of 1000 milliseconds. The setInterval function executes a function repeatedly with a fixed time delay between each call. This is perfect for polling operations, updating user interface elements regularly, creating timers and counters, and periodic data refreshes. The timeline shows how setInterval works with equal time intervals between the function calls. The basic setInterval syntax takes a callback and a time delay in milliseconds. The given example defines a counter and updates it every 1 second using setInterval. It logs the current count and also uses clearInterval to stop the interval when the counter is greater than or equal to 5. Let's discuss some best practices for using setInterval. It's important to manage setIntervals properly using classes. For example, the data poller class has start and stop methods, which use setInterval and clearInterval respectively, to perform polling operations. You also have to take care while dynamically adjusting the interval, since that may cause memory leaks. As shown, you must clear the existing interval before setting a new interval and always clear the interval during cleanup. Let's explore requestAnimationFrame. This is a method that tells the browser that you wish to perform an animation and requests that the browser calls a specified function to update an animation before the next repaint. It synchronizes with the display refresh rate, is battery efficient, pauses in inactive tabs, and is perfect for smooth animations. The code demonstrates how to implement a basic animation loop using requestAnimationFrame. A position is updated, and the updated position is applied to the transformation property of an element. The requestAnimationFrame is called recursively to perform smooth animation. It is also important to cancel animation frame when the animation is no longer needed using cancelAnimationFrame. Let's delve into some advanced animation techniques using requestAnimationFrame. To maintain consistent animation speed across different devices, you should use delta time. The time difference between current and last frame is passed to the animation function, so that speed will remain consistent. When optimizing performance for animation, a fixed frame rate is essential. A class can be used to manage animation loops by using a fixed frame rate and updating only if the elapsed time is greater than the set frame interval, resulting in better frames per second. Let's compare the performance characteristics of setTimeout, setInterval, and requestAnimationFrame. setTimeout has moderate performance impact, with a minimum delay of 4 milliseconds. It is good for non-critical timings. setInterval has a heavy performance impact, since it queues callbacks even if the previous has not completed, which can cause event queue congestion. requestAnimationFrame is optimal for performance, since it syncs with display refresh rate, automatically pauses in the background, and is battery efficient. It is the preferred choice for visual updates. Let's discuss how to monitor the performance of your code. Execution time can be measured precisely using the performance.now method. Frame rates should be tracked to maintain frame timing consistency. Memory usage should also be monitored to identify any memory consumption patterns. The code illustrates how a performance monitor class can be implemented to measure the start time and calculate the frames per second and the frame time using the performance APIs provided by the browser. Let's summarize and discuss the best practices for using JavaScript timing functions. setTimeout should be used for one-off delayed operations. setInterval should be used for recurring non-visual updates. And requestAnimationFrame is best for all visual animations. Some common pitfalls are to be avoided. Don't nest the timing functions. Always clear intervals when a component unmounts. Don't rely on exact timing precision. Some performance tips include using debouncing for frequent events. Monitor frame rates in animations. And batch DOM updates for better performance. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.